Firebase has a long history with real-time sync. Firestore and the original real-time database have made real-time data synchronization seamless for over a decade in the case of RTDB. However, both of these are NoSQL databases. NoSQL is flexible, forgiving, and amazing for many use cases, but sometimes your app and data are better served by the consistency of SQL. That's why we built SQL Connect, a relational database solution from Firebase, powered by Cloud SQL. Our goal was to combine the power of Postgres with the speed and developer experience of Firebase. Let's walk through a sample app together so I can show you just how easy it is to build real-time apps on SQL with Firebase. While this demo is a web app, keep in mind that SQL Connect generates type-safe SDKs for mobile, including Android, iOS, and Flutter, as well as server-side environments, so you can build the same experience across your entire stack. The app is a financial exchange, except instead of stocks, we're trading emojis. Cute, right? It's a perfect candidate for SQL because of its relational structure. Users belong to leaderboards, emojis belong to portfolios, and market trends tie everything together. Financial apps like this are also a classic use case for real-time sync. It's important that users see up-to-date prices and market activity. What did Party Popper close at today? Traditionally, to build an app like this, you're writing a lot of boilerplate code to spin up your server, query your database, and maintain an API layer. Not to mention security. It's not bad, and it is getting easier, but this kind of architecture still requires coordination between the layers of your stack, especially as it evolves. What if I told you that you could scaffold your backend with just 2 files? SQL Connect takes 2 things you probably already know, your schema and the queries you need to populate your app, and uses them to create a PostgreSQL database schema to store your data, a secure API endpoint for each of your queries to talk to the database, and type-safe SDKs to call the API. All right, let me show you how it works. The first step in working with any relational database is defining your data model. Traditionally, you would define your schema using DDL or a modeling tool. With SQL Connect, you define your data model in simple GraphQL objects. If you're new to GraphQL, don't worry. This is a great use case for generative AI, and our tooling will guide you through the correct syntax. Speaking of tooling, I spent years at Firebase designing its UI, so I want to show off how you can do this with the Firebase console. The SQL Connect agent can generate a schema that fits your requirements using only natural language. After initial creation, you can refine the schema with the agent, or directly modify the schema using either the visual editor or the code. Once you're happy with it, you can deploy it. For clarity's sake, I'm going to jump over to the exact schema used in my demo app. Now that my schema's set, I'm ready to write my queries. Well, almost. Before we write queries, let's seed some data to work with. While you could use AI to generate this, I have a seed mutation ready. This is helpful for local development with the Firebase emulator, but can also run it right here in the console. Once this mutation runs, I'm able to browse this data in the table view or run ad hoc queries against it in the query panel. Now that we have schema and data, let's start thinking about the queries we need for our app. The console is a great place to visualize your data, but I'm going to switch to my local setup for this phase. Okay, I've opened the app repo in my editor. I've also pre-configured the Firebase MCP server and agent skills for SQL Connect to help me with this part. Looking at my app's design, I know that I'm going to need a query for all the emojis in descending order by price. I'll generate that query now. Give me all the emojis in descending order by price. Okay, great. This is exactly what I was looking for, but I want to test it to make sure it works. You know, be a human in the loop. To do this, I've installed the SQL Connect VS Code extension, which has built-in query execution, in addition to many other features. The ability to run queries against my local emulator or prod environment is super helpful for rapid iteration. I see the final result, and that the data is coming back in a way that I can easily use in my app. Awesome. For the rest of my queries, I can continue in this manner or write them by hand. Speaking of handcrafted, this is a good time to mention that you can also write queries in raw SQL. Utilizing native SQL is useful if you need to do something more complex, utilize a Postgres extension, or if you just prefer it. Just know that you don't get the type safety that comes with GraphQL. Once I'm happy with my schema and an initial set of queries, it's time to start wiring up my app. SQL Connect takes my schema and queries and generates a custom client SDK to use to query data from my front end. I don't need to write any client-side GraphQL. The generated code will already come with predefined query refs. All you need to do is import them and call execute on them. Okay, I've hooked up the front end to my database, but something doesn't feel right. The emoji prices aren't updating. When I sell a stock, the price should move and my available currency should update. In other words, I think I need to implement realtime. Luckily for me, this can be done in just a few steps. First, we need to make sure that we're subscribed to updates in the client. Those of you familiar with Firestore and Realtime Database and the SDKs know how simple it is to subscribe to updates. With the SQL Connect SDK, the idea is very similar. First, you import the method, and then you integrate it into your app's code. Here's an example using useEffect from React. Now we're subscribed to changes, but we also need to modify the query. Before jumping into the code, let me explain a bit about how realtime works. When it comes to realtime, SQL Connect handles a lot of the heavy lifting for you behind the scenes. If multiple people are subscribed to the exact same query, or if you're just looking up a single entity by its ID, the backend automatically pushes new data to the client whenever a change happens. However, for this dashboard query, I want more explicit control. By adding a refresh directive, I'm telling SQL Connect exactly which mutations should trigger a data refresh. The great advantage here is precision. You get total control over the exact data changes you want your app to react to. In this case, I want to refresh the data anytime someone buys or sells any stock. Here's the refresh directive in action. I have one for buy stock and one for sell stock. You can have as many as you want, but this should be good for now. I'm going to have to redeploy it since my app is running against a production backend. I'll use the VS Code extension again, but you could also use Firebase deploy from the CLI, just like other Firebase products. Okay, it should be ready now. Because I've added subscribe to my front end and refresh to my backend, the app is now fully reactive. Now, when anyone buys or sells emojis, the list view is updated in real time for all users. Everything refreshes, just like magic. Well, that's it for my demo. My name is Marissa, and I'd love to hear your feedback on SQL Connect. If you'd like to learn more, you can try out this sample app by following our code lab in the links below.